אז לדעתי הגענו למסה קריטית של מעל 20 איש, אנחנו נתחיל. אני אבי שקד, אנחנו פה בעוד מפגש מקוון של האיגוד הישראלי להנדסת מערכות. אני באמת אגיד בקצרה רק כדי לא לקחת יותר מדי מהזמן של מייק. אז אנחנו בעצם עמותה ללא מטרת רווח שמטרתה לקדם את חזית הידע בתעשייה הישראלית ואת השיתוף פעולה בין התעשייה ובין האקדמיה בישראל בנושא הנדסת מערכות. אנחנו מקיימים הרבה מפגשי אחר צהריים, במתכונת מקוונת כרגע, בנושאים מגוונים שאתם יכולים להתרשם מהם עכשיו, ובעצם ההרצאה עכשיו אני מזמין את מייק בורגמן שהוא יזם סדרתי מאותר, בעל ניסיון של מעל 20 שנה במגזר התוכנה, הוא מומחה בתכן ובניהול פתרונות תוכנה ויש לו מספר פטנטים בתחום של 2D, 3D Platform Integration Technologies. הוא ידבר על עיצוב חוויית משתמש, גם את האבולוציה שלה, ושימו לב שגם בהמשך השבוע תהיה סדנה בנושא ממשקי אדם מערכת, סדנה בינלאומית שאני מאמין שיכולה לדבר לרבים מכם, אפשר למצוא על זה פרטים נוספים באתר ולהשתתף בחינם גם. אז אני מעביר את השליטה למייק, בהצלחה.
Hi everybody, I hope you enjoy my lecture on UI/UX. Let's get started. In this lecture, I will explain how to design a user interface and create great user experience, the people, the machines, and the learning curve. The lecture will be divided into 3 sections. In the first section, I will explain the technological evolution of man and the human-machine interaction. In the second section, I will discuss the principles and building blocks of UI design and UI architecture. And in the third section, I will connect the dots by demonstrating some real software solutions. There are 2 sides to understanding UI design and UI architecture. The first side is the human element, as it is this user persona that represents our focus, which is to create an interface between man and machine. The second side is the technological aspects, layer upon layer of inventions, to finally produce what we understand today as human-machine interaction. Designing a modern user interface and defining user experience is the culmination of more than 570 years of human endeavor and technological evolution. Let's take a look at some of the history to help us understand the science. Many of the technological terms we use to describe interface elements come from a rich history of technological evolution, starting with the Gutenberg press in 1450. The parameters and terms associated today with the cascading stylesheet language, or CSS, find their origins in the first offset printing press. I will demonstrate how these technologies gradually permeated down to ordinary people, and how these evolving baseline understandings shaped our ability to interact with machines. Common CSS parameters find their origin in movable type settings of the Gutenberg press. For example, typeface, headings, text justification, X height and text alignment, cap height, mean height and baseline, kerning, which is letter spacing, leading, which is row height, content block, padding, borders, and margins were all developed for the Gutenberg typesetting and are used today when building a modern UI. Without understanding these terms and where they come from, it's hard to fully understand how to manipulate them in a browser application today. The importance of these design laws cannot be understated. They represent the design foundations and component positioning rules for all modern software interfaces. By 1450, the vast majority of the world's population were completely oblivious to technological advances. In 1450, except for England and Germany, the rest of the world is still completely in technological darkness. Not all peoples share the same level of understanding and baseline knowledge at the same point in time. 1780 marks the beginning of the first industrial revolution. It is now more than 200 years since the beginning of one of the most incredible periods in human history. The world changed from a handcraft economy to one dominated by industry, machine, and manufacturing. Starting in Britain in the 18th century and from there spread to other parts of the world. Many technological inventions are created for a specific type of industry and problem. These technologies are then applied to completely different industries once they are globally accepted and fully understood. The birth of the calculator in 1822 eventually revolutionized the way all scientific calculations were made. This invention gave birth to the analytical engine and the first programmable computing machine. By 1870, regular people are slowly becoming directly exposed to human-machine interaction and beginning to understand complex technologies firsthand. Women were the first to become exposed to a high level of human-machine interaction via the first mass production machine, the fabric loom. By 1870, human literacy has now jumped to a quarter of the world's population due to the impact of the printing press and its typesetting technology. In 1870, the world's technological advances were limited to England, Germany, and the United States. The rest of the world would enjoy technological benefits of these technologies at a delayed rate. 1870 marks the start of the Second Industrial Revolution. In 1870, the Second Industrial Revolution was another great leap forward for technology and human-machine interaction. In 1876, Henry Ford's motor car and its production line were about to change the face of humanity. Henry Ford brought the rapid advancement of mass production, electrification, and the 5-day workweek to the world. If I had asked people what they want, they would have said faster horses. Henry Ford. This statement speaks volumes about the difficulty when trying to define a product design. A good UI-UX designer must learn to translate what the customer says into what they actually need. This is not an easy task. In 1911, Frederick Taylor wrote The Principles of Scientific Management, which attempted to improve economic efficiency and labor productivity, implementing a scientific approach, training and teaching the worker, cooperating with the worker, and ensuring appropriate division of labor. Using science to understand human-machine interaction takes root in the world. In 1940, Toyota introduced an active QA feedback mechanism. This process provided assembly line workers with the ability to offer observations and improvements to the production process. Feedback is the secret to good product experience. In 1955, Henry Dreyfuss published Designing for People. His design principles set a new standard, and in 1972, Dreyfuss published The Symbol Sourcebook, a guide to international graphic symbols. These are the symbols used in international airports and modern UI interfaces today. When the point of contact between the product and the people becomes a point of friction, the designer has failed. But if people are made safer, more comfortable, more efficient, or just plain happier, then the designer has succeeded. Henry Dreyfuss. By 1970, half of the world was now literate. The Western world and its offshoots are now fully engaged in the human-machine interaction. In 1970, a broad segment of Western society now enjoys a high level of human-machine interaction. Being introduced to technologies from a very early age shortens the learning curve and simplifies a person's ability to understand new technologies. By 1970, the Third Industrial Revolution began. 1970 brought automation and large-scale computers to big business. Large-scale governments and big business begin to harness the power of computing and train specialists to use these tools. A steep learning curve still exists, and only a select few are exposed to this technology. In 1981, the release of Lotus 123 turned the microcomputer from a toy into a serious business tool for the masses. This enabled the average person to leverage complex financial models without having to study economics or mathematics. These spreadsheet applications were referred to as magic. The learning curve is getting shorter, and more people are now being exposed to computer technologies. In 1983, the first GUI-based personal computer was released, and with it, the first engineer complaint. When I saw the Xerox PARC, I saw a caveman interface. You just point and you grunt. A massive winding down, regressing away from language in order to address the technological nervousness of the user. It's interesting to note the refusal of an experienced engineer to adapt to change and simplicity. By 1984, all three big vendors, Apple, Xerox, and IBM, now provided GUIs with various UI components. Not all user interfaces worked in a uniform manner. This confused users. In 1984, the original Apple Macintosh computer came with software, a keyboard, and a mouse. The introduction of the modern UI, natural language functions, and user experience set the standard for UI layouts and UI components until today. From now on, this window layout would become standard for all user interface designs and UI components. Header and footer window layouts, drop menus, the mouse, double-clicking on an icon, drag and drop, natural language used to describe technical naming conventions, all became industry standards from 1984 and forwards. Despite many attempts to try and change and manipulate the consumer, they became the baseline standard. In 1989, the first internet service provider was born. The US and Australia start a revolution. In 1990, HTML was invented, and with it, the birth of the modern UI. In 1992, the World Wide Web was created. The technologies were developed so quickly that the question of how a person interacts with various technologies was often addressed as an afterthought. Mistakes were made. Until 1993, computing technologies were developed and evolved in parallel. The interrelated technologies, such as screens, cameras, hand controls, and keyboards, were all developed separately. These technologies were often flawed in their design. In 1994, Pizza Hut invents online ordering. In 1994, you could sit down at your computer, open your browser, and order a pizza online. As with many technological advances, the market creates new forms of interaction not conceived by the technology's inventors. Who would have thought that eating a pizza would revolutionize human-machine interfacing and create e-commerce via a browser? In 1995, human-machine interaction evolved into the holistic user experience, which refers to the broader understanding of interfacing with a machine. The term was created by Donald Norman, encompassing the overall experience of software and the computer as a complete package. I invented the term because I thought human interface usability were too narrow. I wanted to cover all aspects of a person's experience with the system, including industrial design, graphics, the interface, the physical interaction, and the manual. Donald Norman. Between 1995 and 1997, the way that humanity learned, purchased, and communicated with one another was about to become unified. In 1995, eBay was founded, and in 1996, Hotmail was launched. The year 2000 brought the dot-com crash, and with it, the way that software was to be designed and developed. The interface designs until the year 2000 reflect the tools that were used by engineers to develop them. The software design methodology, referred to as hardware waterfalling, was not producing the required results. This crash was brought about by false hopes and expectations, immature developed methodologies, and a market that was not ready to absorb the massive technological shift about to transpire. Investment business models were also revised and adapted to the new, uncertain reality of software design and the ever-increasing speed of technological advancement. Product UIs designed in this time period didn't generally follow a user flow or workflow design. This confused the users and made learning hard and complex. In 2003, the media revolution begins. iTunes is released by Apple, and the way we digest music and movies completely changes. In 2004, YouTube revolutionizes web-based video. In 2005, the Agile methodology was developed. The focus was to solve user-customer problems and focus on the entire product experience. The Agile mission was to create repeatable and predictable processes that improve productivity and quality. By 2005, almost all the world is now literate and enjoy a high level of technical understanding. In 2005, almost everyone on the planet knows what an app is. Most people now appreciate a good user experience and good user interface design. The customer can now choose from many different products available on the market. They will now start to choose their apps because of the way they look. Features are not the only consideration anymore. 2005 signaled the start of the fourth industrial revolution. From 2005, everything that we thought we knew about the world and human-machine interaction was about to change. In 2006, Facebook changed the world forever by creating the largest unified interactive platform in history. In 2007, the smartphone revolution begins. The Mini app is born, and with it, a clear workflow and repeatable processes will soon become the norm. Humanity will now start to relate to UI/UX of an application in a completely different manner. In 2010, traditional media, such as news sites, news companies, and newspapers, are all already dead, and they don't even know it. Social networks and the smartphone bring a lowering of the age of engagement with advanced technologies. The standardization of the UI is now becoming a consumer expectation. In 2012, the smartphone revolution expands to poorer countries and demographics worldwide. By now, many apps have a clear and focused user flow. Today, almost all desktop applications follow this same methodology. By 2012, modern user experience design evolves, and understandings are reached. First, understand the problem you wish to solve. Then define the product's core functionality. Provide early exposure of the workflow to the customer. Gradually expand functionality according to user feedback and requirements. Create clear and simple workflows. And leverage pre-built components. By 2015, responsive and adaptive UI design becomes standard practice for developing a user interface. Adaptive design ensures the best user experience regardless of the device the user is using. In 2016, the use of standard design patterns becomes widespread. These are reusable UI components and layouts used to solve common problems. In 2017, brain implants are sold, machine learning AI becomes widespread, face recognition systems are implemented, and full virtual reality experience is now available. Now, in 2020, we are entering the era of human-machine integration. There has been an upward shift in the technological baseline understandings by most of the world. In 2020, almost all of humanity is now literate, with a high level of technical understanding. All of humanity is now directly connected to human-machine interfacing via their own personal mobile device. Lessons learned and understandings reached. Human-machine interfacing is always evolving. The interaction is scientific in nature. Baseline understanding is constantly rising. The learning time is getting shorter. The age of engagement is constantly getting younger. User interface design becomes standardized and simplified. User expectations from the UI are constantly rising. Hi again. I hope you enjoyed my brief review of the history of human interface design and human-machine interaction. Now let's go and have a look at the building blocks of UI design and user experience. Before you start to design a user interface, you should understand the basic UI components. I will now discuss the UI building blocks and principles for building good UI and UX. Your product design rides on the collective memory of every application that the user has ever used throughout the course of their life. So they will be looking for controls and functions in specific locations on the user interface. Use standard UI components. Keep interface design consistency. Maintain user interface affordance. Keep it simple. Remember errors and explanations. Help the user learn. Ensure interactive product flow. When discussing the topic of user interface design and user experience, everyone with a pair of eyes thinks of themselves as an expert, so be careful. I will now demonstrate the common screen and page layouts. Containers. A container is the most basic layout element. A container is a UI element designed to display a page component to the maximum width of a user's screen. Containers include other UI components. Certain elements should be collapsible to maximize the interface real estate. You should always consider multiple screen sizes and screen types when you design your product UI. UI components. You can use UI components any way you like, but there are some expected design standards that you should follow. Tables. The table is the first and most basic of all UI components. Tables are one of the main building blocks for all UI design. tables are used in two main ways: as an exposed table element to the user's UI and as a construction frame by the developer. Input controls. Input controls enable the user to input data into the application. Text input fields allow users to enter text. The checkbox allows the user to select multiple items. It is usually best to use checkboxes in a vertical list. Radio buttons are used when the user needs to select one item from the available options. The drop menu list control allows users to select one item at a time from a list. Great for when you need to save space in the UI. Add clear user instructions to the control. The list box allows users to select multiple items at the same time. A great compact control that can support long lists of options if necessary. A button indicates to the user a touch action, and it is usually labeled, applying different colors and shades to show different states of the button. The dual-purpose button provides multiple user interactions. It's great for tight spaces. The toggle switch allows the user to change a setting between two states. Great for touchscreens. A date picker allows users to select a time or a date. Navigation components. Navigation components allow the user to move between screens on an application interface. The search box allows users to enter a keyword and search an index. Search fields are usually single-line text boxes and often come with a search button. Breadcrumbs allow users to identify their current location within a system, and they expose clickable trails of pages. Pagination divides content between pages. These control allow the UI designer to display small packets of data in a single browser view, which reduces UI latency. A slider, also known as a trackbar, allows users to adjust a value, zooming in and out on a map, for example. Tags allow users to create saved content tags for searching. These tags and chip kits are often third-party plugins. Symbol fonts are now being used to replace big raster images for vector images in your HTML browser. Use a simple font for all your application interface needs. Your HTML packet size will now be smaller and reduce latency. A symbol font also makes localizing your interface easier. Remember Henry Dreyfuss from the 1950s? All modern apps utilize his symbol conventions for their buttons. An image carousel allows the user to browse through a set of items without leaving the screen context. Information components provide applications with a means of communicating with the user. Status icons provide the user with information about the current status of a UI object. A tooltip allows the user to see hints when they hover over an item indicating the name or purpose of that item. A progress bar is a time-relative control that indicates to the user the amount of time a specific task should take. These controls are usually not time-accurate. Labels and notification. A notification is an update message that shows something new to the user, used for successful completion of tasks, as well as errors and warning messages. Labeling and descriptions. There is no better place to help the user understand the UI than right there when they're looking at it. Always try to instruct the user what they are looking at and what they can do. A pop-up dialog is a graphical control element, and it is subordinate to the application's main view. A pop-up dialog requires the user to interact with it before they can return to the application's main interface. An accordion is a vertically stacked list that utilizes show and hide functionality. Third-party UI components. A great way to improve your UI is by utilizing third-party UI component libraries. There are many UI component libraries available on the market today. They look amazing and also have another very important benefit. They have been thoroughly pre-tested on all browsers, screen types, and resolutions. They are great, good quality, and a great starting point for any project. They can also add some extra spice and sophistication to your interface design. UI component positioning and style. A UI component state communicates the status of a UI element to the user. Maintain visual consistency for all your UI elements. Each element should have clear affordance. Choosing the right colors for your project is very important, as it sets the tone for your product. Follow the company branding colors and use them to affect the message you wish to create. Today's UI designs rely heavily on motion design techniques. Animations, CSS visual effects, and screen transitions have a huge impact on the user and their interaction with the screen or the product. The UI must support cross-platform and multiple browser types. Today's customers demand freedom and flexibility when interacting with the product experience and user journey, switching between mobile devices and laptops for the same application. Many UI elements have fixed and stretch-to-width configurations. These are industry-standard configurations. I have marked the important ones in red. Collapsing elements are especially good for smaller screen sizes and multiple resolution support. Each dialog and its components contain exact border spacing, component spacing, and position layout standards. These standards are rules that the UI design must comply with. There are many variable factors that determine the layout and framework design rules. These rules are often referred to as artistic when they are really based on screen resolution technologies, compliance requirements, and international standards. Remember this: the layout and positioning principles for an object are the same for a browser as they are for the printed page. Hence, the terminology has remained the same. Without learning where these terms come from, a lot of information is lost. For the designer and the developer, these understandings are critical. The UI style guide is the interface design palette for your application. They enable the UI designer to create a cohesive product user interface and user experience. How to start the design process. The best way to design a great application is to follow a set of steps that help you focus. First, you must understand the problem. What problem does the product solve? Which stress points must be addressed? Where are the core functionalities in the user flow? And how can the solution be most effectively be implemented? Now write up a product brief. Start by writing your brief as single-sentence statements. Select the main functions for an end-to-end flow and then create pixel-accurate mockups. Write up the relevant user stories and keep the design to be the shortest path between 2 points. Create a light prototype for the user flow and expose it to the customer. Implement customer feedback in the prototype where necessary and perform the cycle again until satisfied. Finally, test your application and send it back for fixes until it's bugless. Hi everybody, I hope you've enjoyed everything until now. Let's take a look at some practical examples. I will now demonstrate some real-life products that I've designed using the knowledge and understandings that I've outlined and discussed in the previous 2 sections. The first, building a SaaS product from scratch. The second, converting and upgrading a legacy product to a SaaS product. And the third, utilizing a vector-based prototype builder to build an interactive application prototype. If a picture tells 1,000 words, then a prototype tells 10,000. Building a SaaS product from scratch. The design objective was to design a web intelligence application for collecting, harvesting, and analyzing open source intelligence, and also being able to connect to an external database, search engines, and social networks, as well as geo-positioning tracking data and collecting hidden content from the dark web. The main use case and persona are a data analyst that collects data by utilizing simple and complex search queries, machine learning, and deep learning to improve the search result accuracy through product usage. Main use case, user workflow. A great way to understand the product is to create use case flows. Here you can visualize the user flow and discuss it with the various stakeholders. Because many applications do not flow in a linear manner, the use case flow is especially important to help people understand how the application works. The analyst enters the system. The analyst now defines the case goals and the objectives. The analyst now creates an investigation or multiple investigations. The analyst now configures the data collection keywords and search query parameters. The analyst now monitors the case level statistics and also keeps track of the individual investigations. The analyst can also view the data using different cross-sections of the data visualizations and representations, and further additional views. And finally, create a case and investigation report. This is the case level dashboard. It shows the case level KPIs, the top social network posts by engagement, the author's location, their gender and age, the data collection history of the case. This is usually the last page to be built of an application, as it is derived from the data views created during development. Additional tabs show post-text sentiment analysis by keyword, the collection source of the posts, and the top languages of the posts. The investigation view is accessed by scrolling down the case view or reducing the case window. This view shows individual investigations included in the case. Each tile shows the current state of a specific investigation. The user clicks on the tile to enter the different data views. The user clicks on the plus button to create new investigations. By pressing on the plus button, the first thing the analyst does is to perform a data collection task. The analyst now selects where they would like to perform these searches. They can search in the surface web and the deep web, which includes membership sites, news sites, and online magazines, forums, and blogs. Or they can collect from the dark web, which is the non-indexed part of the internet, which includes peer-to-peer encrypted content. I used the iceberg as a visual representation, as it is the international symbol that represents the internet. The analyst now configures the scope search collection task. The user enters keywords or multiple keywords in the search criteria input field. The analyst can then add complex queries according to different convention used by each social network or engine. This view was designed to provide the analyst with a generic way of creating complex search queries regardless of target source. As each social network and search engine employs different query architecture, we had to find a way of making the experience unified. I used the drop menu to keep it clean and ensure the user does not need to exit the system. The user can easily make changes and or updates by removing or adding chip tags shown here in the orange and blue chips. The analyst then clicks on the Apply button to deploy the scraper collection task. Once the results are returned to the system, the analyst can then view the result snippets and select the relevant preview items to be added to the investigation. The system machine learns the AI according to the analyst's checking items and adds them to the investigation by clicking on the Collect button. The content collected can be displayed using various views in the application. The first prime view is the content view. Each tile contains a headline, a picture, and textual content, as well as comments, likes, shares, and the number of comments collected. The analyst can use the filters to view the collected content according to various available parameters associated with the specific content. The sentiment analysis graph. The analyst can perform sentiment analysis on the collected data. Sentiment analysis refers to the natural language text analysis. I implemented a touch-sensitive bar graph for easy keyword sentiment filtering. The word cloud is also a simple yet powerful visualization that displays the amount of times a keyword appears in a specific collection. The user simply clicks on the word to view all of the relevant content collected. Here we see sentiment highlighting, making it easier for the analyst to decipher the content quickly. The keyword filter. The system automatically divides collected content according to word categories. This is a powerful tool for the analyst to quickly search the database. The connection view. This view shows the relationship between post author and the people that write comments on the post. The analyst can easily see patterns and relationships between people and accurately draw conclusions about the people in the post communication. The extended details. This panel displays the user-selected node items in a list. The user can then click on the list item to view the extended details dialog that shows all of the collected content in context. The action log. Here, the analyst can change the machine learning parameters by scrolling back to a previous configuration search parameter set. The LEDs also indicate the status of the specific collection task, as they can often take a very long time to collect. This is the main investigation management area, where the analyst customizes investigation parameters. This is where the analyst maintains their avatars. An avatar is a virtual social network user profile. This is the social network profile configuration pane. The analyst can add any type of social network user profile from a single pane of glass. This makes it an easy and uniformed process, regardless of the network type. This is the IT dashboard. It is an upsell mechanism. I created the IT dashboard so that customers could monitor their system deployment and purchase more disk space, memory, and bandwidth based on the KPIs that I selected and placed in this view. Converting and upgrading a legacy product to a SaaS product. The design objective was to design an application suite that provides performance monitoring, diagnostics, with a flawless user experience from scratch. The objective was to convert the old legacy interface into a modern SaaS offering. The main goal of this design was to create simple user flows and reduce the amount of pages and clicks. In addition to protecting the customer base of more than 150,000 users, I removed more than 850 screens, which includes thousands of clicks and more than 12 separate external product plugins. The old legacy interface, no user flows, and no end-to-end processes. It's easier to build an application from scratch. It's tougher to take something that has existed for more than a decade and convert it into a sleek user flow and use case-based experience. As you can see here, these screens have absolutely no user flow or clear processes that the user can follow. Just an endless set of tabs, sub-tabs, and sub-sub-tabs, and features and functions in endless lists. Some of the views look like the other views. There's no indication where you are and no process flow. This is the new SaaS product interface that I created by printing out all of the old screens, placing them on the floor, and eliminating the overlapping features and functions. This is the application service dashboard. It is the central location where the user monitors, creates, and maintains their service application portfolio. I singled out the three main KPIs: service availability, service performance, and hardware health systems, as you can see as the three tab controls on each of the tiles. By clicking on one of these tiles, exposes the extended overview of each of the applications over time. By combining multiple separate views and graphs into a single pane of glass, I improved the user understanding and experience and exposed the interdependability of the following system attributes: performance, availability, failures, alerts, and traffic volume. All of the system changes affect one another, and the user could not quickly find out or focus in the system and find out what the actual problem was, because none of this information appeared in the same place. After studying the user log files, I was able to understand the required KPIs that the user was using in order to achieve mission-critical success. Here we see the SLA view, where the user can easily monitor their service level agreements for each of their applications and customers. By clicking on an application tile, the user easily can view the historical data and system downtime for each of the service level agreements. In this view, I used a topology graph to show the relationship between the transactions within the context of a single app. In this example, an online banking application. Here, the user instantly gains understandings about any or all locations on this simple overtime graph and can also compare locations with the click of a checkbox. This is the layer isolation view. The user uses it to monitor the website response time and can use the different time frame selection buttons in the top right-hand corner of the screen to view the different segments over different time periods. The component breakdown details provides the user with a visual understanding of how a specific website loads into a browser client. The world map is what every product manager wants so that they can show this view at an international conference, with lots of LEDs flashing according to the amount of traffic of a particular monitor site. I will now demonstrate how to utilize a vector prototype building application to create interactive product prototypes. For this demonstration, I will be using Adobe XD to build my prototype. I will first show you how to start designing an application. Then I will show you how to build an interactive prototype. And finally, we'll show you how to share the design spec with a developer, including everything they need to build a pixel-accurate application interface that matches exactly the design specifications created here. This is the main canvas of the application. This is where the user affects change and constructs different pages in order to build the application. As you can see on the right-hand side, all the CSS configurations are made here, affecting changes on the panel itself. The user then makes multiple screens, templates, and uses these templates, demonstrated here, to construct flow sequences of the application, as you can see here. Once I've constructed my flow sequence, including all of the elements and items I wish to show or demonstrate for a specific feature or user story, I then can go into the prototype mode, where I can now start connecting all of the different elements and their click sequences. For example, if you look carefully, you can see that each one of these lines is connected to a button. Each one of these links can be attached or detached to a different window to affect and create animative change and fully functional prototype building. Once I've created the prototype, I can then expose it to different stakeholders. They can then go through the click sequence as a user would, fill in the details, activate their account, click on the relevant tooltips, view the relevant information, continue through the click sequence, turning on and off tooltips, clicking on buttons, exposing different views, opening drop menus and scrolling the different options available, continuing down the user flow, visualizing all of the different animations, all the different effects utilized to construct the application itself in order to receive a holistic, end-to-end, pixel-accurate user flow which can be easily translated into the required information for the developer to build the application itself. This is an incredibly powerful tool and it's a revolution. And I can see in the future that this prototype builder will eventually replace a front-end developer's IDE application construction tool. You'll be able to develop the front end of the UI using a visual tool just like this. I hope you've enjoyed this small window and looking into the world of creating interactive UI prototypes, and you'll be able to utilize this information for the betterment of your own products and designs. To flatten the learning curve and to shorten the time to market of a product, it saves time and money and stops many useless and pointless arguments from actually transpiring because the information is clearly transferred from the designer to the developer to the customer in one quick, easy step.